All right, let's say I throw something up in the air. It leaves my hand at 14 meters per second. It's going to go up and then come back down, and I'm going to catch it at the same place it left my hand. So for the entire journey, delta y is equal to 0. For the entire journey, delta y is equal to 0. It travels a certain distance up and a certain distance down. Whenever you have a scenario like that, where it comes back to where it started, the trip up and the trip down are mirror images of one another. Okay, because it travels the same distance on the way up it does on the way down, right? The acceleration is always negative 9.8. And the acceleration, with the acceleration is always negative 9.8, the distances are always the same. And then that means the time it takes to go up is the same as the time it takes to go down. They're mirror images of each other. So, first thing I want to figure out in this question is the total time that this is in the air. Let's just write down what we know. We know that it leaves my hand at 14 meters per second. I throw this thing straight up. It leaves my hand at 14 meters per second. I'm going to catch it at the same place it left my hand. And so for the overall trip, the displacement's 0. It ended up where it started. Remember, displacement's comparing where it stopped to where it started. And then the other piece of information, of course, this is a free fall question. The acceleration's negative 9.8. Negative g. Okay. But wait a second. For the first half of the journey, when it's going up, is the acceleration negative g? Yeah. Because it's going up and slowing down. The acceleration is the rate of change in velocity. It's slowing down as it travels upwards in the positive direction. Negative acceleration. But how about when it's coming down? It's speeding up. Yeah. But it's traveling negatively. Its velocities are increasing negatively. Negative 0 to negative 9.8 to negative 19.6 to negative 29.4. Those are velocities that are increasing, getting faster negatively on the way down. The acceleration due to gravity is always going to be negative because gravity is always pulling down on things even when they're traveling upwards. Acceleration due to gravity. Okay, it's a hard concept to accept sometimes. All right, those are our 3 givens. You notice for all of these equations, you always have to have 3 givens to find the 4th. Unless, well, yeah. Oh, la 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 la. Total time in the air. That's going to be part A. So the total time in the air, given that delta y is equal to 0, there are a number of ways to do this. You do not yet know the final velocity. That's part C. It's not 0. All right. Again, this is all about while it's only in the air, not touching anything. After it left my hand, before I catch it, when the acceleration is negative g. That's only true when there's nothing else touching it and there's no significant air resistance. So I know that delta y is equal to 0. Again, I don't know the final velocity, so I can't use anything with final velocity in it. Okay. I could. There is one other piece of information I do know, and that is that the velocity at the midway point at the top is 0. So I could solve for the time. This is actually a fairly easy way to do it. When it stopped up there, given that's negative 9.8, that's positive, what did I say, positive 14. That would give me half of the time to stop rising, and it would take the other half to come down. So I could solve for that and multiply by 2. But I want to just prove something to you. Part of this is going to be a little proof. And where I'm going with this is that when delta y is equal to 0, the final velocity, when delta y is equal to 0, the final velocity is equal and opposite to the initial velocity. So the final velocity will be negative 14. That's one of the things I wanted to show you, but I'm going to prove it to you. All right, so the equation I'm going to use is this one. Delta y equals v sub 0 y times t plus 1/2 ayt squared. Now notice that this is 0. Actually, I'm going to do a little factoring here. I have a t here, and this is t times t, so I have t common to both terms, and so I can factor out a t here. That's v sub 0 y plus 1/2 ay t squared. Not t, I mean. I factored out the t. There's two ways you could do this. You can go through and divide by t. 0 divided by t is 0. That gets rid of that t. And then I'm just end up with this. But I do want to point something else out that relates to your algebra. Right? Now I have two roots, right? What are the two different solutions for t that make this thing 0? Well, this whole thing will be 0 when t is equal to 0, which I guess I'm asking the question, there are two times when this thing is at 0. When it leaves my hand, that's the first root. When it leaves my hand, which is at 0 seconds, that's t equal to 0, it's at 0. When's the other time it's at 0? That's going to be this time. That's when it's come all the way back up and come back down again. So you can solve it like that, solving it for roots. One of the roots is t equal to 0, and then put that equal to 0, and you find the other root. Or you can just divide through by t. This is the way I prefer to do it. 0 divided by anything is 0. The t's cancel out to 1. So we end up with 0 equals v sub 0y plus 1/2 ayt. You solve for t, and it equals negative. And here's this 2 right here, negative. So subtract that to the other side. It's the negative sign. Subtract that to the other side. This is this 2. Multiply both sides by 2. And then divide through by that. And that comes out to be negative 2 times 14, all of negative 9.8. And the answer for this then is 2.9 seconds. Let me just double check that looks right. So 28 divided by 9.8. Yeah, 2.857, so 2.9 seconds. Okay. How about the maximum height? How high does it go? Well, there's a couple ways to do that. I'm going to put a max there because it's the maximum height, just so I don't confuse it with the delta y equal to 0. That's all. Some people use an h, whatever. Now, there's two ways to do this. At maximum height, how long does it take to get up there? Well, it takes half that time. So I could put that into here using half of the time. I also know another really good piece of information, and that is that its velocity in the y-axis at the maximum height is 0. It has stopped at that point. So there's a variety of ways to do this. I think that I'm going to use this second equation and use half of that time. So this delta y max will equal 1/2 v sub 0y plus vy at the maximum height, which is where it stopped rising. And I'm going to use t max, which is just the time at the maximum height, all right? So that's 1/2 times 14 plus 0 times 2.9 all over 2, right? Because I'm using half of the time. Half the time it took to get up there. And that should come out to be 10 meters. 10 meters.